Welcome back as we extend the production function to consider more sources of GDP growth. We'll examine the role of labour and human capital, ICT and non-ICT capital, technology, public infrastructure and natural resources on the potential GDP of an economy. Let's get rolling. We've learned in the first lesson the production function, where aggregate economic output is expressed as a function of physical capital and labour, given a level of technology which we term as total factor productivity as the multiplier. The Cobb-Douglas function is one common production function that's based on this premise. The extended production function expands this to include a number of less obvious factors. Besides the labour supply, we consider the human capital, which is the skills and education level of the workforce. Physical capital is separated into ICT capital, non-ICT capital, and public infrastructure capital. The function also considers if natural resource is an important factor. Let's examine each of these components. Firstly, the labour input is defined as the size of the labour force, multiplied by the average hours worked. Labour force is defined as the number of working age people available to work. This includes both the employed and unemployed. Thus, growth in the labour input depends on four factors: population growth, increase in labour force participation, net migration, and average hours worked. Let's study each of these four factors in further detail. Population growth is determined by fertility rates and mortality rates. Low fertility rates are a particular concern in several developed countries like Japan and EU countries. This is why population growth rates are significantly lower in the developed countries than in the developing countries. The demographics of the population is also important. Countries that have a higher proportion of working-age population will tend to see its labour force decline when these people retire. Many developed nations fall in this category. Conversely, countries that have a higher proportion of young people are more likely to have higher potential growth when these young people enter the workforce. Developing nations fall into this category. Labour force participation is defined as the proportion of working-age population in the labour force. Working-age population usually refers to people between 16 to 64 and includes both employed and unemployed. If you recall from level 1, the unemployed refer to those who are looking for a job. The participation rate has trended upward in most countries over the last few decades because of rising participation rates among women. Another factor that increases population growth is immigration. We mentioned earlier that several developed markets face the prospect of shrinking workforce due to an aging population. Immigration is a possible solution to make up the shortfall in labour. Besides the number of people working, the average hours worked per worker is also an important determinant of the growth in labour input. For most countries, average hours worked is on a downward trend. Possible reasons include legislation limiting the number of hours worked, the wealth effect, which induces individuals to take a break, high tax rates on labour income, and an increase in part-time and temporary workers. In addition to the quantity of labour, the quality of the labour force is an important source of growth for an economy. Human capital is the accumulated knowledge and skills that workers acquire from education, training, or life experience. Obviously, a better educated and highly skilled workforce is better able to take advantage of technology to improve productivity and increase output. Furthermore, education may have external spillover effects as knowledgeable workers innovate. Innovations are then used by society in general, creating greater efficiencies in the economy. Physical capital is generally separated into infrastructure, computers, and telecommunications capital, and non-ICT capital, which include machinery, transportation, and non-residential construction, and public infrastructure capital, like airports, roads, and bridges. Let's put this aside for now as we make comparison between ICT and non-ICT capital. In general, countries which have put in higher proportions of its GDP into physical capital investments experience higher GDP growth rates. For example, capital investments in China has been consistently more than 40% of its GDP in the past decade, much higher than the rest of the developed nations. As we've learnt in the Cobb-Douglas production function, growth in labour productivity is the result of capital deepening and technological progress. The thing is, capital investment can take different forms. Some capital investment actually influences technological progress, thereby achieving both effects at the same time. In general, ICT investments have a greater effect on improving TFP than capital deepening. On the other hand, non-ICT investments into construction, transport equipment, and machinery have greater effect on capital deepening than improving TFP. Developed nations which are already high up on the capital per worker scale typically make more ICT investments to boost growth, as it has already hit the diminishing marginal productivity limit. For example, the investment from developed nations in the past few decades in the IT sector has resulted in network externalities. The more people that get connected through the internet, the greater the potential productivity gains. The effects of the network externalities are largely captured in gains in total factor productivity rather than capital deepening. And that inadvertently brings our discussion to technology, which by now you should be convinced is the most important factor affecting growth of per capita GDP. Technological progress is the multiplier that makes it possible to produce more in terms of quantity and quality with the same resources or inputs. Besides manifesting through physical capital investments, technological progress should also be manifest through investments in human capital. A better trained and educated workforce is required to produce, implement, and operate better technologies. It's not easy to quantify or measure the level of technology of an economy. Researchers have examined proxies such as R&D spending or number of patents issued. Developed countries tend to spend the most on R&D since they rely on technological progress for growth given their high existing capital stock and slower population growth. In contrast, developing countries often copy the technological innovations of developed countries and thus invest less in R&D as a percentage of GDP. Another form of capital investment is the building of public infrastructure such as roads, bridges, and municipal facilities. Besides the direct boost to GDP, such public investments, if done strategically, can provide additional boost to the productivity of private investments. For example, the money spent on building an airport does not just give a one-off boost to GDP. The airport, when operational, has the potential to enhance productivity for private investments by improving the imports and exports efficiency of the goods and services. Now let's address the big question here. Is possession of natural resources essential for GDP growth? Natural resources include both renewable resources, such as timber, and non-renewable resources, such as oil and gas. The role of natural resources in economic growth is complex. If possession of natural resources is necessary for GDP growth, we would find most countries to fall within this band. For example, some Middle Eastern countries, Brazil and Australia, have high per capita GDP because of their resource base, and resource-poor countries like some African nations have low per capita GDP. Yet, if we look around, there are plenty of anomalies. Some of the resource-rich nations, Venezuela and Nigeria, have low per capita GDP, while some resource-poor countries like Japan, South Korea and Singapore have high per capita GDP. Let's study some of the possible explanations for these anomalies. One reason that limited natural resources do not necessarily constrain economic growth is that access to natural resources does not require ownership of resources. These resource-poor countries that experience high growth are very open to external trade, such that they can easily gain access to natural resources that they lack, so it's not a limiting factor to growth. For some countries, the presence of natural resources may even restrain growth, resulting in a resource curse. There are two main reasons why this may occur. First, such countries may get complacent and fail to develop the economic institutions necessary for growth. Second, countries rich in resources may suffer the Dutch disease, where currency appreciation driven by strong export demand for resources makes other segments of the economy, in particular manufacturing, globally uncompetitive. And these are the 7 key components of the extended production function. In our next lesson, we shall learn the theories of growth. See you again.